for the uniform convergence of this given series, and the interval is also given to us. So this is your given series with the given interval. We can write this series as summation n going from 1 to infinity. In the numerator we are having 2, 4, 8. So we write 2 to the power n and x to the power 1, x to the power 2, 3, so on. So here also x to the power n. And in the denominator we are having 1 plus the even powers of x, right? So we write here x to the power 2n. Now to test for the uniform convergence, we need to apply the Weierstrass M-Test. For that, we need to consider the mod of this. So consider summation n going from 1 to infinity mod of 2 to the power n x to the power n divided by 1 plus x to the power 2n, which can be further written as summation n going from 1 to infinity 2 to the power n mod of x to the power n divided by mod of 1 plus x to the power 2n. As n is starting from 1 to infinity, this denominator is positive. So this is further less than equal to summation n going from 1 to infinity 2 to the power n mod of x to the power n. Right? Okay. What is the interval given to us? From here, we are having mod of x is strictly less than 1/2. If I apply this over here, what I get 2 to the power, this is strictly less than 2 to the power n into 1 divided by 2 to the power n. That is equal to 1. But for the Weierstrass M-Test, we need to have the convergent series on the right hand side. So let's consider mod of x to be less than equal to alpha and it is less than equal to 1/2. So applying this over here, we get further it is less than equal to summation n going from 1 to infinity 2 to the power n into alpha to the power n. Reason? Mod x is less than equal to alpha less than equal to 1/2. Please mark this as 1. To apply the Weierstrass M-Test, we need this series to be a convergent series. How can we get this series to be a convergent series? There is one more test, that is D'Alembert's test. So we can take the help of the D'Alembert's test over here. What that test says that if you consider this to be your an, then if limit n tends to infinity on an divided by an plus 1 comes out to be strictly greater than 1, then the summation n going from 1 to infinity on an is convergent. That is, then this summation 2 to the power n into alpha to the power n is convergent. So let an is equal to 2 to the power n into alpha to the power n, and an plus 1 becomes, just replace n with n plus 1. So it becomes 2 to the power n plus 1 into alpha to the power n plus 1. Taking the ratio an divided by an plus 1, that is equal to 2n into alpha to the power n divided by 2 to the power n plus 1 into alpha to the power n plus 1. So this becomes 1 divided by 2 alpha. Taking the limit n tends to infinity on an divided by an plus 1. So we get there is no n, so it is 1 divided by 2 alpha only. Now to check whether it is greater than 1 or less than 1. If it is greater than 1, then the series will be convergent, right? Okay, let's check for alpha. What is alpha? Alpha is strictly less than 1/2. That implies 2 alpha is strictly less than 1. That is 1 divided by 2 alpha is strictly greater than 1. So 1 divided by 2 alpha is strictly greater than 1, which means the series is convergent now, right? That is, this series is convergent. So by D'Alembert's test, summation n going from 1 to infinity on an is convergent. That is, summation n going from 1 to infinity, what is an? It is 2 to the power n into alpha to the power n is convergent. This is what we need for the Weierstrass M-Test. Because this right hand side series is convergent, so by Weierstrass M-Test, this given series is uniformly convergent. Thus, from 1, we have marked this to be as 1. So from 1, in view of the Weierstrass M-Test, the given series is uniformly convergent for the interval x greater than -1/2 and less than 1/2. Thank you.